In early 20th century Britain, aviation was a science without rules, a race of inventors, dreamers and soldiers trying to understand the air itself. Among them was a quiet engineer named Geoffrey de Havilland. He was not famous, nor formally trained, but in the space of a single decade his designs helped carry Britain from fragile wooden biplanes to the foundation of a global aircraft industry. Geoffrey began his work in 1909 when heavier-than-air flight was still viewed as a novelty. Using borrowed funds and hand-drawn plans, he built his first airplane in a small shed near Seven Barrows. It lasted only seconds before crashing. Most would have stopped there. He didn't. The failure taught him something critical, that control, not power, was the real challenge of flight. A year later, his second design lifted cleanly off the ground. It was crude, unstable and underpowered, but it flew. That single success set the course of his life. When the First World War began in 1914, Geoffrey's designs filled the ranks of the Royal Flying Corps. Thousands of BE-2s were built and deployed over France and Belgium. They became the eyes of the army, slow, steady and dependable. But as the air war evolved, those same traits became weaknesses. Against the faster, more agile German fighters, BE-2 crews were often outmatched. Many pilots called them flying coffins. Geoffrey, though not responsible for their continued use, carried that criticism for years. He had built for stability. The war had moved on to combat. By 1910, the British government had established the Royal Aircraft Factory at Farnborough, hoping to formalise aviation research. Geoffrey joined as a designer and test pilot. He quickly earned a reputation for precision and practicality, an engineer who understood both the workshop and the cockpit. His BE series, short for Blériot Experimental, focused on stability and safety. The BE-2, first flown in 1912, became Britain's standard reconnaissance aircraft. It wasn't fast, but it was reliable. A platform that allowed pilots to fly in formation, photograph targets, and guide artillery with accuracy unknown in previous wars. In 1915, Geoffrey left Farnborough for Airco, a private manufacturer where he could experiment more freely. There, he designed the DH.2, Britain's first successful single-seat pusher fighter, with the propeller mounted behind the pilot. It was a direct answer to the German Fokker-Eindecker that had dominated the air. The DH.2 restored balance to the skies, and British pilots once again gained control of the front lines. The initials DH began to mark a new era. His DH.4 bomber followed soon after, fast enough to outrun enemy interceptors and capable of carrying a meaningful bomb load. It became one of the war's most respected designs, used not only by Britain, but later by the United States as well. In 1920, using personal savings and a small team from his wartime staff, Geoffrey founded his own aircraft company at Stag Lane Aerodrome in North London. His goal was no longer to build machines for war, but to design aircraft ordinary people could fly, safe, elegant, and efficient. His first successes came quickly. The DH-50 opened new routes for civilian travel, while the Moth series, simple, inexpensive, and reliable, made private flying possible for thousands. The Moth became the symbol of interwar aviation in Britain, training a generation of pilots who would later fight in the Second World War. Despite his growing influence, Geoffrey remained largely unknown to the public. Newspapers celebrated aces, not engineers. His aircraft carried other men's names, squadrons, generals, and manufacturers. By the time Airco was absorbed into a larger industrial group after the war, Geoffrey's identity had almost vanished behind corporate logos and factory labels. But the end of the war gave him something he'd never had before, the freedom to build on his own terms. Geoffrey's designs shared a unique fingerprint, light structures, clean lines, and a deep respect for the materials he used. While other manufacturers turned to metal, he continued to work with wood, refining it into an art form. He believed that weight, not horsepower, was the true measure of progress. By the late 1920s, his company had grown into one of the most advanced aircraft builders in the world. Yet he remained modest, rarely granting interviews or seeking publicity. His satisfaction came from the machines themselves, from knowing they worked exactly as intended. As the 1930s approached, the world once again drifted toward conflict. Geoffrey's lightweight designs, admired in peacetime, would soon be judged in war, and his faith in wood and aerodynamics would lead to one of the boldest aircraft ever built, the plane that proved speed and simplicity could outmatch armour and guns. It would become known as the Mosquito, the most unconventional success story of the Second World War. By the mid-1930s, Geoffrey's company had established itself as a cornerstone of British aviation. The Moth had opened flying to civilians across the Commonwealth, and the Dragon Rapide connected cities faster than any train could. But a new reality was emerging. Germany was rearming, and Europe was once again preparing for war. The question was no longer how to fly farther or faster, it was how to survive. The British Air Ministry was focused on heavy bombers and defensive fighters. Their strategy assumed that armour, guns, and metal construction were the future. Geoffrey disagreed. He believed that a bomber's best defence wasn't armour, it was speed. If an aircraft could fly faster than a fighter could intercept it, it wouldn't need guns or gunners at all. It was an idea many dismissed as fantasy. When his team presented early sketches of a fast, unarmed wooden bomber, officials at the ministry called it impractical. Metal was seen as the only modern material. Wood was considered obsolete. Yet Geoffrey understood wood in ways his critics didn't. Properly laminated and reinforced, it was light, strong, and easy to shape. It also didn't corrode, and Britain had a supply of skilled carpenters, rather than the aluminium reserves Germany controlled. In 1938, he began quiet development of the aircraft that would test that theory. A sleek, twin-engine design that combined fighter speed with bomber range. His engineers nicknamed it the DH-98. On paper, it defied military convention. It had no defensive guns, no armour plating, and relied entirely on twin Rolls-Royce Merlin engines and an extremely smooth wooden frame to outrun danger. As the war erupted in 1939, official interest in unconventional aircraft disappeared. The Air Ministry wanted quantity and firepower, not experiments. The Hurricane and Spitfire dominated orders. Geoffrey's wooden prototype was quietly shelved. But within a year, that attitude would change. By 1940, the Battle of Britain had proven that speed and agility, not brute strength, decided survival in the air. Fighter Command's thin margin of victory shifted priorities across the Air Ministry. Geoffrey seized the opportunity to revisit his idea. He argued that a high-speed, all-wood bomber could perform reconnaissance missions and precision strikes beyond enemy radar range. He promised to build it faster than any metal aircraft then in production. The ministry reluctantly approved a prototype order. The project was codenamed Mosquito. Construction began in secret at Geoffrey's Hatfield factory in Hertfordshire. The design used a sandwich of birch and balsa wood, strong, lightweight, and ideal for mass production in civilian furniture workshops rather than overburdened aircraft plants. Engineers worked through nights under blackout conditions, shaping moulds and assembling frames in total secrecy. In November 1940, the first prototype rolled out. It looked nothing like a conventional bomber. It was small, aerodynamic, and unarmed. The military observers who attended its debut remained skeptical. But on the 25th November 1940, test pilot Geoffrey Jr., the founder's son, took the aircraft into the air for its first flight. The results stunned everyone present. The Mosquito was faster than any British fighter then in service. At full power, it exceeded 380 miles per hour, nearly 20% faster than the latest Spitfire. The speed, combined with its altitude performance, made interception nearly impossible. Within minutes, the test flight had turned skepticism into silence. Geoffrey knew he had built something that would change the war. Yet the real challenge was convincing the bureaucracy to believe it. Production space was scarce, and official orders favoured armoured aircraft. For months, the project survived only through persistence and private funding. Then, in 1941, the first operational tests began. A Mosquito reconnaissance variant crossed the North Sea to photograph German naval bases, and returned unscathed, having outpaced every Luftwaffe fighter sent to intercept it. The data it brought back was clearer than any obtained before. From that moment, the Air Ministry's resistance vanished. Orders multiplied. The Mosquito went into full production, adapted for bombing, pathfinding, and photographic intelligence. Its all-wood construction allowed small workshops and furniture manufacturers across Britain and Canada to contribute to the war effort. The plane's versatility was unmatched. It could carry 4,000 pounds of bombs, deliver them with pinpoint accuracy, and still outrun enemy pursuit. The aircraft's nickname, the Wooden Wonder, spread through Allied squadrons. Pilots trusted it for missions no other plane could survive. Whether flying deep into occupied France or striking Gestapo headquarters in Copenhagen, the Mosquito proved that design philosophy could overcome material limitations. For Geoffrey, it was vindication. The same wood that officials had once dismissed as outdated had become the backbone of Britain's most advanced aircraft. Yet even as production accelerated, he rarely appeared in the press. The credit, as always, went to the machines rather than the man. By 1943, Mosquitoes were flying in every major Allied theatre, from night raids over Berlin to precision strikes in Burma. They served as fighters, bombers, and reconnaissance aircraft, each variant sharing the same defining trait: speed. In many cases, they reached their targets hours before radar operators could react. Inside the Hatfield factory, Geoffrey's engineers pushed for refinements: longer ranges, heavier payloads, and more powerful Merlins. The aircraft's wooden body made field repairs easy, even in remote bases. Production topped 7,000 units by war's end, built in Britain, Canada, and Australia. But the Mosquito's success came with personal cost. In September 1943, Geoffrey Jr., who had performed many of the prototype test flights, was killed during a trial of a new jet-powered aircraft. The loss struck his father deeply, yet he refused to slow the work. The younger Geoffrey's name remained in every test log that followed. By the time the war ended in 1945, the Mosquito had achieved legendary status. It had proven that a small company, working against official opinion, could produce one of the most versatile and successful aircraft of the entire conflict. And for Geoffrey, it marked both a triumph and a turning point, because the same daring that had created the Mosquito would soon push him toward an even greater challenge: the first true jet airliner. When peace returned in 1945, Britain's skies were filled with thousands of Geoffrey's aircraft. The Mosquito had proven the company's engineering excellence, but the transition to civilian life posed new questions. What was next for a company built on wartime innovation? For Geoffrey, the answer was clear. The jet age had arrived, and Britain could not afford to fall behind. The company began converting its wartime capacity into peacetime production. Factories that once turned out wooden fuselages now produced transport aircraft and trainers. But Geoffrey's focus was not on rebuilding what had been done before. He was already looking beyond propellers. In 1946, his engineers started early development of jet propulsion for commercial use, a concept that few at the time believed would be viable outside military programs. Geoffrey had been experimenting with jet technology since 1941. His company had produced the Vampire, one of Britain's first operational jet fighters during the final months of the war. It was small, fast, and built largely of metal, a sharp break from the wooden designs that had defined his legacy. The Vampire entered service in 1946, confirming that his company could adapt to a new technological era. Still, Geoffrey's ambitions went beyond combat aircraft. He envisioned a passenger plane that could fly twice as high and twice as fast as any propeller-driven transport. The project, initiated in 1946, would become the DH-106 Comet, the world's first commercial jet airliner. It was a bold and risky move. The industry believed jets consumed too much fuel and required too much maintenance to be practical for civil aviation. But Geoffrey saw an opportunity to establish Britain's leadership in a new global market. He poured company resources into research, wind tunnel testing, and engine development. The engines themselves, the Ghost turbojets, were built in-house by his engine division, another sign of his insistence on self-reliance. In July 1949, the first Comet prototype made its maiden flight from Hatfield. It climbed smoothly into the sky, silent compared to the roar of piston engines. Within minutes, it had reached an altitude that no airliner had ever achieved. For the press and the public, it was a symbol of a new era. Britain had beaten the United States, France, and the Soviet Union in the race to build a jetliner. When the Comet entered commercial service with BOAC in 1952, it represented a technological triumph. It could fly from London to Johannesburg in less than 24 hours, a route that had previously taken nearly twice as long. Passengers travelled above weather systems, in pressurized comfort, surrounded by sleek windows and a quiet cabin. It was aviation's future, realized years ahead of its time. But success came at a devastating price. In early 1954, several Comet aircraft suffered catastrophic mid-air breakups. At first, the causes were unclear. Investigators suspected sabotage, engine failure, or turbulence. But as wreckage was recovered from the Mediterranean, a pattern emerged. The airframes had failed under stress at high altitude. The Comet's pioneering pressurized fuselage, one of its greatest innovations, had also become its weakness. The inquiry that followed was exhaustive and historic. Sections of the aircraft were reconstructed at the Royal Aircraft Establishment in Farnborough, where engineers simulated repeated pressurization cycles. The results revealed what no one had fully understood. Metal fatigue, caused by stress around the square windows, had led to microscopic cracks, which expanded until the structure failed. It was a flaw born from pushing technology faster than testing could follow. For Geoffrey, the news was devastating. The Comet had been his crowning achievement, a statement of what British engineering could accomplish. Now, it was grounded worldwide. Production halted. Airlines cancelled orders. The United States, which had been trailing behind, accelerated its own jet programs with lessons learned from Britain's mistakes. Within a few years, Boeing and Douglas would dominate the skies Geoffrey had opened. The official inquiry absolved the company of negligence, acknowledging that the science of metal fatigue was poorly understood at the time, but the damage was irreversible. The Comet's failures marked a turning point, not just for the company, but for the entire British aircraft industry. Geoffrey took responsibility publicly and privately. He oversaw redesigns that included rounded windows, reinforced fuselages, and improved testing standards, innovations that later made all jetliners safer. The improved Comet 4 eventually returned to service in 1958 and performed reliably for years, but the prestige of being first had been lost. Despite the setback, Geoffrey continued to innovate. His company developed the Dove, a twin-engine passenger plane, and the Caribou, a rugged transport aircraft for short takeoffs. His designs became essential for both civilian and military use, spanning continents and decades. Yet the Comet disaster haunted him. He rarely spoke about it publicly, but colleagues described a change in him, a quiet withdrawal from the excitement that had once driven his work. He continued to attend meetings and review designs, but his focus shifted from bold experimentation to reliability and safety. By the late 1950s, Geoffrey's company remained a respected name, but faced growing competition from larger manufacturers. The British government began consolidating the aviation industry to cut costs and standardize production. In 1960, his firm was absorbed into the Hawker Siddeley Group, ending the independence of one of Britain's most iconic engineering houses. For Geoffrey, it marked the end of an era, the closing chapter of a life spent turning fragile wood and metal into machines that carried nations through war and into peace. Retired quietly, recognized but rarely celebrated, his name more familiar to engineers than to the public he had served. Yet every aircraft that followed bore traces of his philosophy: simplicity, balance, and belief in the harmony between design and purpose. As he entered his final years, he had lived long enough to see the jet age he had envisioned become an everyday reality. Airliners crossing oceans with ease, passengers no longer marveling at what once seemed impossible. But few remembered that it began in a small shed at Seven Barrows, with one man's determination to understand how flight could be made better, faster, and safer. By the early 1960s, Geoffrey had become a symbol of a passing age, one of the last great independent designers who had built Britain's air power from the ground up. He was knighted in 1944 for his wartime service, but the honours never changed him. His focus had always remained on the work, not the recognition. Even as the industry he helped create grew larger and more bureaucratic, he maintained the same principles that guided him from his first wooden aircraft: precision, simplicity, and integrity. The company, now part of Hawker Siddeley, continued to produce aircraft that bore his design legacy. The DH-121 Trident, a jet airliner developed in the late 1950s, carried forward his pioneering work with pressurised cabins and swept wings. Its technology directly influenced later British designs and eventually contributed to the development of the Airbus generation. Yet Geoffrey himself had already stepped back from daily management. He spent his later years mentoring engineers and reviewing designs as a consultant. Colleagues described him as calm, reserved, and meticulous, a man who preferred quiet discussions at drafting tables to speeches or publicity. His workshop remained his refuge. Even in retirement, he continued to refine small aircraft models and engine concepts, purely for the satisfaction of solving problems. Though his contributions were widely respected within aviation circles, the public often associated the name Geoffrey with the company's products, rather than the man himself. The Moth, the Mosquito, and the Comet had become household names, but few outside the industry knew they all originated from the same mind. He seemed to accept that anonymity. He had once said, "An aeroplane must speak for itself. If it is right, it will tell its own story." In the decades that followed, the world of aviation changed faster than even he had imagined. Jet travel became routine, and the very idea of airliners as luxury experiences gave way to mass transportation. Geoffrey's early principles, aerodynamic efficiency, material discipline, and simplicity of form, were now embedded in every aircraft design philosophy. His insistence on testing, his approach to composite materials, and his lessons learned from failure became part of the DNA of aerospace engineering. Yet progress also came with personal loss. Geoffrey never fully recovered from the death of his son, Geoffrey Jr., in 1946, during a high-speed test of the DH-108 Swallow, an experimental jet that explored transonic flight. The accident was one of several tragedies that haunted the post-war years of the company. The elder Geoffrey rarely spoke about it, but friends said it left a permanent quietness in him, a sense that the cost of innovation could be greater than the success it brought. Despite that, he continued to advocate for experimental research and remained convinced that aviation's future depended on courage and discipline in equal measure. He often reminded younger engineers that perfection was never final, only a temporary state before the next problem appeared. When he died in July 1965 at the age of 82, tributes poured in from across the aviation world. Fellow pioneers like Sir Frank Whittle and Barnes Wallis acknowledged that without Geoffrey's groundwork, Britain's air industry would never have achieved the dominance it briefly held. His funeral was private, fitting for a man who had avoided the spotlight all his life. In the years since, Geoffrey's name has been rediscovered as part of Britain's engineering heritage. The Aircraft Museum, located near his old factory at Salisbury Hall, preserves many of his designs, including a Mosquito prototype built in the same hangar where his team worked under blackout conditions during the war. Visitors can still see the wooden moulds and blueprints that defined an era when innovation depended more on intuition than on computers. His influence remains embedded in modern aviation. The use of lightweight materials, aerodynamic simplicity, and integration between engine and airframe, all standard today, reflect his philosophy. The success of composite aircraft like the Boeing 787 or Airbus A350 echoes Geoffrey's belief that material science, not just power, determines progress. He lived through the birth of flight, the brutality of 2 world wars, and the dawn of the jet age. Few men in history witnessed such transformation, and fewer still shaped it as directly. He began as a self-taught craftsman working by candlelight, and ended as a knighted engineer whose designs crossed continents and defined generations. Yet perhaps his greatest contribution was not a single aircraft, but an attitude. That innovation is the product of persistence, and that failure, studied honestly, is the most valuable tool an engineer can possess. Every Geoffrey aircraft, from the fragile BE-2 to the elegant Comet, carried that principle into the sky. Today, when a passenger jet climbs effortlessly above the clouds, it does so on the foundation of lessons learned by people like him. Men who believed that progress required risk, and that mastery of the air was not about power, but understanding. Geoffrey never sought recognition, but history eventually caught up with him. His name now stands among the quiet architects of modern aviation, those who built machines not to be admired, but to endure.